Hello and welcome to another one of these ADD videos. We're going to be looking at second order differential equations, just discussing the basic idea of what's going on here. So as the name implies, a second order differential equation will have some sort of form of the second derivative in it, or higher order necessarily. It doesn't have to be second order. They all behave in this manner. And there's two types. There's going to be a homogeneous equation, or homogeneous, however you want to pronounce it. Yes. If it's equal to 0, and if it's equal to some function g of t, or x, or whatever it's in terms of, it would be a non-homogeneous equation. And you'll be finding a particular solution for those. And we'll go over that video separately. This video is going to deal with what you need to do first for all of these equations. Is pretty much look at the homogeneous equations. And what you'll be doing is you'll be setting up what's called a characteristic equation. And in a characteristic equation, what you're going to be doing is you're going to be transforming each prime into a power of r. So if it was y triple prime, that would be an r cubed. Double prime, oops, let's do 2 hash marks instead of squared. That would be r squared, and then single prime would be r, and then no prime would just be the coefficient in front. Okay, so what you'll do is you'll set up a characteristic equation. It'll be some polynomial, r squared plus 3r plus 2 equals 0. You'll factor it, and you'll get r values. It doesn't necessarily have to give you real and distinct roots. Okay, so what do we do from there? Well, we have to come up with a homogeneous solution, and there's a few types, and they depend on your r value answers. So the general solution, if it's two reals, so 2 real roots, what you do there is you plug in to y equals c1 e to the first root, and we're talking about distinct roots, not repeated roots, x, or actually x or t, or depends on what your independent variable is, c2e to the r2x. Alright, then if you have 2, or actually 1 repeated root, meaning it, r equaled 1 twice, or you have r minus 1 squared, then you do y equals c1 e to the r, because it's only one r, I don't need to distinguish it, x plus c2x e to the r x. And then if it's 2 imaginary solutions, it's going to be y equals, this is based off of alpha plus beta I, or a plus bi, however you want to look at it. It would be c1 e to the alpha t sine beta t, or c2 e alpha t cosine beta t. Squeeze that in there, hopefully. Alright, so it's kind of crunched in. Let me clarify that just in case you can't see it. That's alpha t, and then cosine beta t. And just like anything else, you can be given initial values, y of some x value equals some other value, and you can plug in, or actually t in this case, because I put x's for the first two and t's for the other, so I'm going to change these to x's to keep them consistent. It's actually kind of sloppy. Let's erase that. But as I was saying, you can solve any initial value problem given the fact that you're given a t and an y, or an x and a y. You can solve for C1 and C2, and what will happen for that is you'll get a system of a couple of equations. Just going back through and putting the same variable for all these, so it'll be uniform. So if you plug in, they'll give you y of a number, and then they'll give you like y prime number equals something else, and you'll get a system of equations where you'll have to solve for C1 and C2 algebraically. And that's basically the concept. Okay, so let's recap. You're going to have to first take your homogeneous equation and find the characteristic equation. After you convert to your r's and whatnots, you're going to get some equation that looks like that. You're going to factor it and solve for r, and then you're going to have a few types of plausible scenarios from that. You could have two distinct roots in which you'd come up with this characteristic equation, one repeated root, sorry, it's the same root if it's repeated. You get that in that scenario, and then the imaginary roots. Alright, so that's the concept. Make sure you check out, there should be an example video for the two real roots, the two repeated roots, and the two imaginary roots as well. I hope this has clarified any doubts that you might have, and again, check out the example videos, and more importantly, practice, practice, practice. Thank you, and have a nice day.